All right, let's finish to talk about later. All right. So again, if anything else, I'm just going to look at this problem and say, you know what? I probably need to simplify something here. So if I looked at this in terms of x's and y's, again, another problem over here. If I looked at this in terms of x's and y's, I could say this could be x plus 1 times x minus 1 all over like y squared. Would everybody agree with me? That's like an algebraic way to represent that problem. Correct? Now, if I was going to say, hey, could we simplify anything with this algebraically? Could I multiply these two?
They cancel each other out.
Well, the middle terms will cancel each other out. So this would be a representation of a difference in two squares. Right? Yes. That's okay. So if I was going to multiply them out by using FOIL, what I'd recognize, Zach, is that this is a difference in two squares. So in reality, the middle terms cancel out or go to 0. And I have x times x, which is x squared. And 1 times negative 1 is negative 1. Is everybody OK with me writing it as x squared minus 1?
Sure.
Everybody understands why I don't have to do all of FOIL?
Sure.
OK. Well, all right, so that becomes x squared minus 1 over y squared. Now, as far as algebraically, I've pretty much gone as far as I can go algebraically, right? That's where the next step, identities, comes in. Now we got to start using our identities. So let's go and apply it to actually our problem. So therefore, we know this simplifies to secant squared of theta minus 1 all over sine squared of theta. Now, on your trigonometric identities, there is another Pythagorean identity. And that Pythagorean identity says 1 plus tangent. 1 plus tangent squared of theta equals secant squared of theta.
There's also 1 plus cosine.
Right, cosecant, actually. And I think I wrote it wrong. But anyways. So anyways, this happens all the time. So if you guys look at this problem, right, this is an identity. An identity means the left side is equal to the right side. You guys also learned about identities in Algebra 1. We solved equations. Equations that were true were called identities. The left side was equal to the right side, right? X equals 4 would be considered like an identity, right, once we've solved our equation. So what I'm saying is if with identities, there's something that was really important. And that was what we called the properties of equality. When you have an identity, whatever you do to one side, you have to do to the other side, right? Do we know what secant squared of theta minus 1 is in this case? No, we only know what secant of theta is. But is it OK to subtract a 1 on both sides?
Sure.
Sure, of course it is. Now, what does secant squared of theta equal? Tan squared of theta. So now I will replace secant squared of theta minus 1 as tangent squared of theta. So you might say, OK, now we're done, right?
Nope.
Not close. We're almost there. But now in this problem, we still want to get this down to one trigonometric function. So I go back to what does tangent represent? Well, when tangent had an angle with crossing a point on the unit circle, we said it was y over x, right?
Sine theta over cos
Correct?
theta. Yes.
OK. But what did on the point on the unit circle, what represented y? Sine. And what represented x?
Cosine.
So would it make sense then to also say that the tangent of an angle is equal to sine over cosine? Would that make sense? OK, good, because that's what it means. So tangent squared of theta is equivalent to sine squared of theta over cosine squared of theta divided by sine squared of theta. Well, to kind of make further sense of this, if you need to simplify this now, I would, yes, write it over 1. So therefore, I could reason, oh, multiply by the reciprocal, which Mr. McLogan says all the time. You do that on the top and the bottom. Because any number or any expression multiplied by its reciprocal multiplies to 1. Over here, the sine squares divide out. And we're left with 1 over cosine squared of theta. And if you guys remember my initial definition of the reciprocal function of cosine, which was secant squared. Anybody have any questions on that? No preguntas.